Hey everyone, I'm Philip from Baseten, and I'm super excited to be here with Corey.
Yeah, I'm Corey Quinn from Duckbill, where I historically focus on AWS and then by extension cloud bills. And increasingly, all of those are starting to look an awful lot like AI inference bills. So it seemed like we should probably sit down and chat on camera one of these days. That day's today.
It sure is. I mean, we got to figure out what we're spending all our money on.
It's a weird workload in that it is a lot more variable than any other cost historically. Yeah, people get surprise cloud bills all the time, but surprise inference bills, that's not as easy to diagnose. It's a misconfiguration where you're routing traffic in a loop. That jumps out pretty effectively. Or, we spun up a bunch of things we didn't know were there. Cool. This is agents making decisions on their own in potentially expensive ways, hitting token budgets, and people don't build, circuit breakers in, so they just run through them forever. Model upgrades mean that things work differently. Everything thinks now with a latest model jump that didn't in a way it didn't before. So now it's basically being paid to talk to itself. It's also an emerging space where no two use cases are quite alike, and everyone tends to go at it a little bit differently in the era of inventing their own.
Yeah, I mean, let's take the most simple possible example. I am working on a coding agent, and I say, write me what's something that's easy to vibe code, maybe a visualizer for my AWS bill that I'm going to put in, the CSV of all the money I spent, and it's going to show me where all of it went. What the coding agent's going to do is it's going to say, okay, I need to first off read this CSV. I need to build an HTML file. I need to write some CSS to make it styled nicely. And I need to do all of these different pieces. And it's going to do that reasoning loop. And depending on what the model is and, what the random number generator spits out, this reasoning loop could be a widely variable number of tokens, and you're paying per token throughout that loop. And then possibly it's going to spin up sub-agents to go out and write each of these individual pieces, or to go do research and figure out that this is actually a very difficult problem. And so, it's gone from maybe trying to one-shot it to trying to build a much more complicated system. And all of a sudden, the question that I asked is consuming millions of tokens to come up with a good answer. And I realized that I was very wrong. And it turns out that this stuff is very complicated and not one-shot to vibe code. And along the way, I've managed to spend a whole lot of money to learn that lesson, or at least a whole lot of tokens. So you take that sort of experience, multiply it across a software developer in the course of their daily work, multiply that across a week, a month, a year, multiply that across a team, an org, a company, an entire economy, and all of a sudden you have a lot of token spend. And you have a lot of unpredictability around that token spend, because if you can't even predict what any individual task is going to cost, how are you going to predict what your entire usage is going to look like?
I wonder how representative the software development workflow is when it comes to something like that, because when you start having inline AI as a core offering of someone's product, which businesses are finding some success in and others they're aspirationally hoping to do it. Take an airline, for example, of, someone's going to say when they're trying to travel, turn that into an API request. That feels like a relatively bounded problem space. You can pretty accurately forecast what the cost of that request is going to be. But that feels like the old school Gen AI approach as opposed to the more agentic approach of, okay, now go and grab the ticket. Now go gather their preferences for a book from seating. And there's no erase condition. Turns out someone took the seat you were attempting to book. And effectively, you wind up with wide swings in a per invocation of that agent, just in terms of cost. It becomes non-deterministic by any traditional method.
Because one thing that defines an agent is that an agent should be able to unblock itself, which means you can't, work around this. There's two examples that I try to give for this. Number one is, to sound smart, I say, think back to the classic computer science problem of the halting problem. We don't even know how to predict when an ordinary program is going to finish. How are we going to know when to predict that a AI invocation is going to finish? And then the other example, and this is, something much more personal. I don't know about you, Corey. Maybe you've solved this in your life, but if you ask me how long something's going to take, I'm going to give you a number. And no matter what number that is, it's going to be wrong. And generally, it's going to be wrong in the sense that whatever I think it's going to be is going to take much longer than I predicted. For example, I think it takes me about 2 weeks to write a book, and I've never written a book in 2 weeks. That's for sure. So if we can't even predict how long it takes for ourselves to do tasks, how are we going to predict how long it takes an agent to do it?
Well, Claude and Claude Code has gone through a bunch of iterations where it'll wind up saying what it's going to do next, and it starts giving estimates. Like it turns into a 6-week project. It's like, well, get after it then. And of course, within an hour, it's done with the entire thing because I'm not actually building something at massive scale and that level of complexity. But even computers can't figure out how long it's going to take. In fact,
maybe it's just flexing on you. It's like, well, this would take you 6 weeks, but I'm going to do it in an hour.
Now, what I love about it, though, is it's the first time I've seen an estimate be too long. Usually, if I ask you to tell me how long something's going to take, mentally, I'm probably multiplying that by 3 as just a general base rate. If in the event I'm not familiar with your work and your level of doing estimates, this can lead to some really wildly inflated stuff. And in corporate life, that's almost an anti-pattern because if you say, oh, this thing is going to cost $6 million, the budget gets denied. But if you say it'll cost $2 million, it'll get approved, as will the $2 million extension, as will the second $2 million extension. And now you're right where you predicted it was going to be, magically, but that's the path to getting it accepted as opposed to vetoed with the sticker shock.
Yeah, you have to anchor low and then rely on sunk cost fallacy to get you the rest of the way there.
I've been saying for years that cloud economics is more psychology than it is arithmetic. Customers lie, mostly to themselves. They earnestly believe things to be true that in many cases were at one point, but now are not. Even the comment I just made about an agent doing an airline booking thing, you're right, it's non-deterministic to figure out what that's going to cost. But now imagine a world where you have that happening 30,000 times an hour. You can get some pretty accurate numbers with, yes, there's going to be some outliers, but within a standard deviation, you can pretty rock solidly predict what's going to happen cost-wise until the model changes or your inference provider shifts on some level and there's been a fundamental shift. Okay, when I see a stepwise function in the cost graph of that application, which is its own magic because very few people have that level of granular visibility into their environments, then you get to play the fun game of what changed. And maybe what changed isn't even you. Maybe it's something in the critical path with one of the providers you're using.
And one thing along with that is when you are looking at this new model adoption process, you know, the thing that everyone likes to put in the headlines is the cost per million tokens. But that's actually not a very good representation of total cost, because if I switch to a model that costs half as much per million tokens, but it takes twice as many tokens to get to the answer, I haven't actually saved myself anything in terms of cost or in terms of time.
Oh, and from model to model, even with Anthropic, we're seeing a 35 to 40% increase in number of tokens for a given input or output, even before you get to the reasoning piece of it. So what is a token is one of those variable equation aspects.
Yeah. I mean, the token as a fundamental unit of accounting is still quite strong, but definitely telling an incomplete story. It's something that I think about a lot with the switch to open models. One of the most common criticisms of open models is in many cases taking more reasoning tokens to get to a high quality output. Now, I do think that this is somewhat overstated for a couple reasons. The main one being that oftentimes people are shoving open models into harnesses designed for one specific model and the pattern of that model. And so if it's almost like going into someone else's house and trying to use their computer to do your work, everything's just going to take a little bit longer. But at the same time, you also see patterns where in some cases the open source models are more reasoning efficient, and then you compound on your savings. So it's a complicated setup where you almost have to benchmark every single task a little bit before you start to run it at scale and make sure that you have a good estimate of kind of not the outcome, because as we've said, you can't predict outcomes, but the distribution of outcomes. Because once you have that distribution, you can multiply it by your scale and come up with a reasonable range of expectations.
One of the things I love doing is being deliciously, wonderfully, horribly wrong, usually in public. And one way that I was in the early days of AWS's Bedrock offering, which is sort of, they're going to run a bunch of models and then give you all the wonder and power and the simplicity of AWS billing combined with IAM. Terrific. That's going to go super well. Just layer, let's say, all right, what if I wanted to use Anthropic's API, only make it 20 times harder? Great. Bedrock is for you. They were saying, Andy Jassy on earnings calls and a bunch of other places and stages and whatnot was that the future was multi-model, which is exactly what I would expect someone to say in the event that they didn't have a good model of their own. It's, well, yeah, no, you can't say that OpenAI is going to run away with it because then you don't have anything to sell. And I thought that that was a temporary inflection, that there's going to be this sort of one or two amazingly powerful God models that you can drop anything into and it'll do that thing super well. And I could not have been more wrong, because specialized work cases, specialized classifiers, everyone seems to be doing a different thing and switching models for different tasks left and right. I'm glad I was wrong. I didn't want this to become a monopoly or a duopoly of, okay, you have just these two big models that everyone uses and the rest of us serve at their pleasure. I really like how the world has gone in a direction where there are so many good models to choose from that you wind up almost with analysis paralysis of which one you go for.
Yeah, at some point you just have to pick a model that does reasonably well and kind of build from there. I think that what we see increasingly is models saturating a given intelligence benchmark. And then what you do is you shift your thinking. Once getting smarter doesn't help you, you want to get faster and you want to get cheaper. Generally, the way you do that is you get smaller. You take a model with fewer parameters, train it up to do just as well on that given task, and then you can create that specialized model, move a workload over to that. We see that more often in products. There's two places that inference is used broadly. Internally for things like coding agents and other internal workflows, and then externally to make an AI-powered product like the, airplane booking agent that you were discussing. And we generally see more fine-tuned models used in the external products, the customer-facing products, because those often have much more specialized workloads. The thing that the major labs, the open source labs, everybody is working on in their base models is coding ability. So for most of the internal workflows, especially the internal coding workflows, we see more of the base models used directly because that's the thing that they're already designed to be good at, is writing code. Now, of course, writing code is that general purpose capability, right? So you were saying, maybe I want to book an airline ticket. Maybe I want to write code that books the airline ticket. Maybe I want to, write an API call, execute that API call, etc. So there's, some sense that maybe coding is the general thing that solves all problems, but in fact, you actually generally turn to specialization for that.
Yeah, it feels like it's a software engineer's disease to think that code solves all problems, because when the only tool you have is an axe, every problem looks like hours of fun. Same problem. Yeah. Where I'm going to go and, I know how to write code to solve this problem. I will say that my own use of bespoke internal software has proliferated massively since the rise of these things, because I'm garbage at anything remotely resembling front end, and I'm never going to get other folks to use no matter how clever the interface is, a CLI script in order to wind up solving a business function. But now, dropping a quick tool internally where people can click a button and get a response, it's magic.
What does your setup look like for that, and what are you building with those?
Oh, dear Lord. So my entire development environment is, I'm going to be objective here, it's insane. I run an EC2 instance in its own AWS account. That account is called Superfund because it is both toxic and expensive at the same time. I give Claude or Codex each their own EC2 instance. They have root on the thing. But the key point is that there is no data inside of these accounts. So all it can do is blow out my AWS bill, and I have some confidence that my tooling will catch that. It's going to have to really plan hard in order to get around that. So from there, I wind up having it build a bunch of nonsense, depending on what moves me at any given moment. And the promotion process is via GitHub Actions, which then takes that, deploys it onto either my home Kubernetes cluster, as everyone has, right? Or into a work Kubernetes cluster for our internal tools approach. And that deployment winds up iterating forward. That's for the in-house tools, the things that aren't critical path. Skyway, the product that we're building, we have a bit more rigor around the engineering team and releases and what AI can and cannot do with it. But the beautiful part about being me and with what I'm building, it doesn't need to interact with anyone else. I mean, just like the worst founder you've ever met, main is my feature branch for these things. If it doesn't work the next time I try it, I can roll back or fix it iteratively forward. You can't do that with paying customers, especially external ones in most environments.
That's one thing I'm seeing a lot of is, with these internal tools, building entire separate environments for them to live in that are as far away as possible from production, and then I've also seen cool things like, for example, having a wrapper layer around every tool where every tool gets deployed to its own subdomain. They have, a consistent sign-on in front of them and, maybe like an Okta authentication or something. And then, within that environment, you can kind of do whatever you want, but nothing is going to, mess with any kind of actual critical system. And it's really cool to see the infrastructure be stood up for these internal agents as a kind of parallel world to the main production systems.
What is interesting to me about these agents, and there are, of course, exceptions out there, but by and large, when I'm running Claude code, it doesn't need a whole lot. Okay, objectively, it needs a gig of RAM per session because I don't know what they're bloating into that thing, but whatever. Assuming you have sufficient capacity to run the session itself, all it's really doing is making calls to external inference providers, which vary, and waiting. It doesn't need a whole lot of oomph itself. It's not doing a lot of compilation, generally speaking. I learned early on, though, to give it a fairly sizable swap partition in case it needs to bloat out a bunch of RAM so it doesn't OOM kill itself by starving the box of RAM. But by and large, it sits there idle and waiting most of the time, which unlocks some interesting approaches. I mean, I could theoretically run this on my laptop, except for the small problem of, one, my laptop turns off sometimes. Two, I don't like having a lot of local stuff running because I have other things on my laptop. I have access to customer data through the nature of what I do. I want there to be a hard barrier between that and any self-evolving system that winds up deciding today that, our computer? You mean my computer? I'm going to use that for my own purposes for whatever reason made sense to it at the time. I like the fact that I'm not beholden to having any state on my laptop. So when I trip and drop the thing into the bay, all I lose is the value of the hardware, which these days is not small, compounded with, I'm just going to basically reassume a TMUX session on that EC2 box and pick up where I left off.
Yeah, you're not one of those guys who's walking around with the laptop cracked open, waiting for the agent session to finish.
No, that I've seen people do that, and I sort of get where they're coming from, but with a little bit of planning on this stuff, it gets a lot easier. I've had a couple of times where the agent has blown out my entire source tree that has all the projects on it, but EBS snapshots are great for being able to restore that. I've had a couple of fun instances of weird network reachability, but given that all my nodes live on Tailscale, that solves a whole bunch of security issues, that solves a bunch of accessibility problems, and it's a big flat network between all of my devices and nothing else. It's magic.
Turns out maybe agentic infrastructure is just the infrastructure we made along the way.
That's what I'm starting to believe. I did a whole blog post, Substack rant about a month ago of the 14 things that an agentic cloud needs before I will accept that you've built the thing properly. And everyone's talking about the sandboxing and the permissions, credentialing, and the rest. It's cool. I want to go a little deeper. I should not have to spend half a day setting it up with all the provisioned access that it needs. It should not have to. One of my favorite things that convinces me that computers have some of the same limitations that we do is watching all of these models struggle with and fail to get an AWS CLI command right in the first 3 attempts because there is no consistency to its parameters between different services, just like their APIs. It is a nightmare, and it has to basically stumble its way through and check the docs and then get it wrong because the docs aren't quite right. And, computers, they're just like us because that's how I use these things. Only they're faster at doing the typing bits than I am, which is awesome.
They can fail faster. More trials, more errors.
Exactly. It also makes me feel a lot less dumb when I watch the super smart robot from the future have the exact same problem. Like, oh, right, it's an AWS experience problem. Yeah, it's not a me problem.
Yeah, you can solve a math problem with a Fields medal, but you can't make an IAM credential in under 5 minutes.
Oh, sure you can. The trick is every human does this. They just allow star because you keep trying to do the right thing with least permissions and doesn't work. Expanded a bit, doesn't work. Expanded a bit, doesn't work. Screw it. Star, like I did on my last code build job 5 years ago with a to-do of come back and fix this later. And 4.5 years after that, I finally went back and decommissioned the whole thing. It was still running with all of those permissions just because it's the failure mode of if I can't figure it out, I have a real job to do, and that job is not figuring out weird permissions on something that doesn't have access to sensitive data.
One thing I wanted to mention, you talked about how your harness, whether that's Claude Code or another one, basically does 2 things, which is make API calls and wait. Mm-hmm. what we've been, experimenting with that around that is you as the user of the harness can actually more or less decide where those API calls go. So we just built this thing for we call it Baseten switch that lets you switch different models. So for example, in Claude Code, you could maybe keep Fable, but switch Opus for GLM and switch, Sonnet for DeepSeek. And then you can kind of see the token savings on the real workload as that runs for a day or a week or a month. You kind of see what you saved versus what you would have spent on those other models. And it's really interesting now. I think back in the day, every developer had their own IDE, and we had the IDE wars. It was like, I use Emacs, I use Vim, I use Atom, I use VS Code. And now there's a lot of developer preference around harness. So if you go within a given company, some people are going to be Codex people. You've got Claude Code people, Coso people, Cognition people, Open Code people, Factory people, Pi people. You've got a whole long list. And
yeah, I've been using T3 Code last week or so to wind up driving a bunch of these sessions in various places. I think we're going to see a congealing of these things, I hope, because I don't think everyone wants to go out and build their own custom harness from scratch, given that we aren't that different from one another. I think we're going to see a leader or two emerge, ideally open source, where you can drop in whatever agent or session that you care about, but the way that you orchestrate this starts to consolidate around those things, because everyone building their own is such a waste of time, talent, and tokens.
You would think, but don't we have, still Vim, Emacs, Nano, TextEdit, and a whole laundry list of ways to write code by hand?
Oh, absolutely we do. But what we don't have is everyone writing their own text editor the way that we used to in computer science class early on, of learning that, this simple thing is way harder than we thought.
Of course, but you still have a plurality of options in the market.
Of course.
And a text editor is, somewhat simpler than a complete agent harness. Although, the implementation is probably somewhat more detailed.
You say that, and yet we have Microsoft Word as counterexample.
That is
continue.
true.
The worst IDE ever.
Yeah, but good for books.
Exactly.
What I'm kind of getting at, though, is that what I'm seeing is enterprises are accepting the idea that developers, at least at the present moment, do not want to be forced into a single harness. And that just like there was preference around developer environment, there is now preference around coding harness. So what they've been starting to do instead is try to create the consistency at a series of routers and gateways so that, you can, again, sort of intercept whatever requests the harness wants to make, and then route them appropriately, track the spend, track the token usage, and create some degree of consistency on the operational and management side, while still allowing for heterogeneity in the sort of front-end interface that is the harness.
I recently did a bit of a dive into model routers because I had a thesis that, again, was delightfully wrong, which was that a lot of enterprises were using them because they cared very much about latency and availability of their model providers. It turns out that none of them are. I could not find a single example. And when I look at the model as a service companies, the open routers and the rest, every single one of them, as of this recording, talks about their enterprise customers in very vague terms that you use to discuss my girlfriend in Canada. You wouldn't know her. She goes to another school. It doesn't have a lot of authenticity tied to it. The people using those model router services often do it to test a bunch of different models quickly. But every enterprise is on some level exploring a router, usually something internal, to wind up doing not latency or reliability, but rather routing between models for different requests, and more importantly to them, attribution of what is making these calls and how do we figure out the cost center tied to them. Because getting a giant bill from Anthropic at the end of the month, okay, great. What drove this? Everything is not a great answer. You have to understand the contributors to that bill.
Exactly. And so I do think that over time, there will probably emerge, like you were saying, one or two solutions that do very well on this market. I think that right now everyone feels like their problem is special and no one else understands how hard it is to, account tokens between teams. I do think that there is something to be said for building some pieces of routing and some pieces of gateway internally, both for integration into the rest of whatever sort of single pane of glass you use across your organization, as well as for building internal understanding and internal competence around the way these things work. But if you look at, for example, the very, very hard problem of task-specific routing, saying like, I'm going to take easy tasks and give them to cheap models and hard tasks and then give them to good models, which sounds great in theory, but is actually very difficult because it's hard to know ahead of time whether something's going to be easy or hard. You ultimately start to see, common pieces in this puzzle that I do think over time folks are going to go out and buy for the most part rather than reinventing the wheel. We're just so early on this. Like, people only started freaking out about token costs like 3 months ago.
Right. 4 months ago, they were having a tournament competition leaderboards over who could set the most money on fire. Yeah, it's amazing that people started caring right after the first billing cycle after that particular experiment.
Yeah. That's very, very good tailwind for us, honestly, is everyone waking up on the same day and caring about cost.
Yeah.
But it's still really now only been about a quarter since then, which, I've been learning that in big company years is not very long.
No, that is underpants outside the pants superhero style speed.
Yes, exactly. So it's still very early in the router and gateway story. I believe that once the common patterns emerge, that there's going to be, more of this shared between companies versus everyone kind of doing their own bespoke thing. And then, all evolution leads to crabs. All, router and gateway building is going to lead to a pretty similar outcome.
Yeah, talking to the enterprise heavy folks that I was feeling out on the model router story, I was asking them about this. A couple of them were building these weird bespoke things, but the common points that emerged were around Light LLM and Bifrost, both of which are open source, and crucially for them, both of them also offer enterprise licensing and support tied to it. So it's sort of the best of both worlds. But okay, why would you not use a third-party service? The answer was, we're enterprise. Everything lives in our data center. In fact, we built out a GPU cluster and we wind up doing inference locally on it. It's like, how's that going? And they said, next question, please, in that panicked way that tells you exactly how that's going.
Yeah, I mean, inference is a very hard problem, and I can see why you would look at the landscape of open source software and you would look at, the ability to buy some GPUs and plug them in and say, I think we got this. But it's actually quite complex because the workloads are hard to forecast. The models are constantly changing. If you had, for example, built an entire infrastructure stack 2 months ago around the idea that open source models are not more than 1 trillion parameters, then Kiely K3 and Quinn, the Quinn 3.8 are going to come along and completely destroy that assumption for you because they're 2.5 trillion parameters. And now all of a sudden, your B200s that you bought and set up because you thought that you were only going to do 1 trillion parameter models, you're making the choice between slow multi-node inference or, throwing them all in the trash and going out and getting some B300s. So there's a lot of difficulty around the predictability, and then there's this entire new discipline of inference engineering where you need to either go out and hire very scarce, very expensive engineers who have done this in the past, or you need to take your existing engineers and you need to retrain them very, very quickly on a wide range of new technologies, from all the way down from like the CUDA level to the runtime to applied research to a lot of infrastructure stuff. Actually, it turns out more and more what I'm seeing in the inference game is, obviously the runtime stuff is important. It's super cool to talk about. Everyone wants to talk about like their latest speculator, but success in production predominantly comes down to infrastructure expertise.
Yeah. And if you train people up on being those inference engineers with all of those skills that you just named, not everyone can come along for that ride, especially at scale. And what you're also doing, even in the success path, is do you realize the multiplier you've just done to their market value on how that works? Like you pay market rate for the talent you have, whether you want to or not. It is a scarce resource and will continue to be a scarce resource.
Absolutely. And frequently I'll meet, some mid-level to maybe senior individual contributor within an enterprise who does know this stuff extremely well and who enjoys it and builds on it. But due to the structure of the business, they're not sufficiently empowered to be the leader of the inference strategy, even though they're the one with the technical knowledge to get it done.
Yeah. People can only handle being that kind of frustrated for so long most of the time, where they want to start using these skills and applying them. And it's an exciting time. It's the first time since the dawn of computing. We're seeing computers doing what you mean instead of what you literally tell them to do.
Exactly. And it's a hard skill to develop too. Something that people ask me about a lot that I'm still trying to figure out the answer to is, how do I practice hands-on inference engineering skills? It's a bit of a chicken and egg problem, right? Because you can only, especially the infrastructure stuff that I want to talk about here, like you can only do this by operating large systems at scale and, orchestrating hundreds of thousands or millions of dollars worth of hardware. That's the only way to actually get hands-on with these problems.
I made a bigger sewing room with a loading dock.
Exactly. But you only get the opportunity to work on these problems once you've already proved that you can solve them. So it's a chicken and egg problem where, on the runtime, you can tell people, contribute to open source, try local inference, do this project and this project to, at least get some level of fluency with the topics. If I say, I want you to get really good at moving around the KV cache, you're going to need some place to store it, some place to move it to, and some place to move it back to. And all three of those cost money.
Absolutely. Okay, I built a small crappy version out of Raspberry Pis or Jetson Orin Nanos floating around. Great, cool. That's not directly congruent to the skills you'll actually need. It's similar to, I want to learn to work with big data, but the only data sets I have all fit on a USB drive. Like, okay, maybe think a little bit bigger. It's hard to do. It's hard to bootstrap yourself into learning these things without a corporate sponsoring environment that you can get the scale in. Scale is its own skill, and you need it for this.
Exactly. And that's one of the privileges of working at a startup is that you can start out operating at that very small scale and then learn with every order of magnitude along the way versus being dropped in at the very largest scale.
It's a wild experience. It keeps repeating. If you're looking at this massive scale problem you're dealing with, it's like, how are we going to solve this? And you stop sometimes and think like, in 18 months, we're going to think this was quaint. Yeah. It keeps coming.
18 weeks in many cases.
Oh, yeah. Well, it depends on the lead time for shipping GPUs these days, but yeah.
That is true. The amount of planning ahead that we have to do now is substantially higher than it used to be.
Significantly so. So something that I have been paying attention to for a while has been the gap between closed models and open models, to a point where now it seems like instead of being 6 months or a year, it feels like it's measured in weeks at best. What is that?
Yeah, it's a couple factors. So number one, it's open models simply getting better faster because in the open ecosystem, you're able to learn from each other. Let's take a fun example. So GLM 5.2 came out about a month ago, still a very, very popular model, very capable, about 1 trillion parameters, so nice mid-sized model. And GLM is a great model and especially great at front-end coding. But it does not have vision. You can't give it a screenshot and have it look at it and say what's wrong with the input, with the image. So we decided to build that. We had one of our researchers took the encoder from Kiely and trained from scratch a projector, which is this little 80 million parameter layer that takes the input from the image encoder and maps it onto the weights of the model. It's important to do it this way versus post-training the model itself, because this way you don't change any of the model weights. You don't run the risk of introducing any kind of regressions in capability in order to add vision support, because, sometimes if you teach a model one thing, it forgets other stuff. So you're not running the risk of this. The trade-off is, of course, the vision support isn't necessarily at the frontier, but it's good enough for the specific use case we were trying to unlock of being able to, within the coding harnesses that we've talked about, offer compatibility with the feature of progressively feeding back images throughout the front end process so that you can make nice tools instead of CLIs.
Or even my manual process of I took a screenshot because does this look right to you? It turns out I'm a total jerk, and sometimes the way I talk to an agent when I'm frustrated. But yeah, I asked it 3 times to make it work correctly, and it's not working correctly. What gives?
I mean, if you asked GLM what gives, then it's going to be like, sorry, bro, I can't look at the screenshot. So we added this vision encoder, and ultimately what this little, Franken model came out as is you have the GLM weights, which run, by the way, using DeepSeek sparse attention, and the Kiely vision encoder off of 2.6, not off of 3. All 3 of those working together to create a new model that is more capable than anything previously. So I think that's a big aspect of it, is we're seeing with the large number of labs and the large number of researchers working on these open model problems, we're starting to see the network effects of open source supporting each other and learning from each other. And we're also just seeing an increase in scale. There's so much more demand for open models. We're also seeing an increase in scale. There's so much more demand for open models. There's so much more attention in this space. There's so many more people building on them, that, of course, they're going to keep getting better and better. And what I'm most excited about is the range of options. It's not just what it has been, which is a kind of like mid-size model that is a generation or so behind the state of the art. What it is everything from something like Kiely K3, which is not the best open model. It's not a frontier open model. It's simply a frontier model that happens to be open, all the way down to small models. You've got, the Laguna models from Poolside. You've got DeepSeek V4 Flash. You have Gemma 4. You have a large number of models in that like 30 to 200 billion parameter range that are extremely fast, extremely cheap. And if you go back even 6 months or a year, you'd look at it and you'd be like, wow, this thing is a genius. And, today maybe it's only the 9th or 10th smartest model in the world, but on a price performance ratio, it's simply unmatched.
It's almost like bandwidth, where when we first got a cable modem and suddenly saw something faster than 56K, it was incredible. And now you look at the 1 megabit we got back then, it's like, is this thing even on? Like, I have a multiple of that on my phone when I'm pulling up random web pages now. You're used to what's current, and it becomes old news very quickly. But you take one of these mid-tier models that now runs on a phone or a laptop or other consumer hardware, go back in time 3 or 4 years, and suddenly you have the best model on the planet. It's not particularly close.
Qwen 3B, back in the day would have blown minds. And it's exciting for me personally, because when I came into the tech industry in, 2017, 2018, when I was in college, I heard about stuff like Moore's Law, and I heard about, all of the generations of iPhone improving, all of the generations of cloud improving. And it seemed to me like things were only kind of getting incrementally better. And I'd missed out on what the industry looked like when things were doubling in quality every single year. And now things are, getting twice as good more than once a year. So it's a very exciting time. And I'm very thankful that I got to be a part of one of these sort of exponential runs like we saw in the past in all of the many different technologies that are now just an ordinary part of our life today.
Predict the future slightly on this for me. Are we going to see a plateauing of these models? Are we going to see them continue to evolve? Do we see open models overtaking the frontier closed models?
Well, there are some fundamental limitations. There's the hardware limitation, of course. The big limitation is actually not so much around what model you can train. You can train a model of pretty much arbitrary size. It's more about like how big of a model can you run inference on at a scale that is commercially viable. And the answer right now on, the latest Blackwell generation is about 3 trillion parameters. Anything beyond that starts to get very, very difficult unless, I suppose you could have maybe a 10 trillion parameter model that you exclusively do wide expert parallelism on GB300 NVL72s, and you have an entire rack as a single replica of the model, and that gets very, very expensive very quickly. Obviously when the Rubin generation comes out, the GPUs are going to get much faster. There's going to be more interconnect, which helps a lot with multi-node. But at the same time, you're still looking, at least to my knowledge, on the R100 or whatever the sort of base spec one is that comes out. To my knowledge, I believe it's going to be the same amount of VRAM as the B300, so that 288, and maybe if you forecast ahead and imagine the growth of VRAM amounts continuing as it has from Hopper to Blackwell to Rubin, maybe we get to, something close to twice that, but you're still looking at a few trillion parameters. You're not unlocking, 10, 20, 50, 100 trillion parameter models. There's some bottleneck in hardware, to be sure. There's some bottlenecks in data. There's some bottlenecks in, simply the amount that you're willing to spend on a training run.
Yes, my budget is always a limiting factor eventually.
Our budget collectively is going to be a limiting factor eventually. When you look at the amount of CapEx that's going into this space, like, at some point, you run out of money in the world if you think that you're just going to scale exponentially forever. But I do think we're a long way from saying like, hey, we're finished. This is as good as models are going to get.
We're now at the end of history, the end.
We are not. There's still a long way to go, both in terms of sort of headline capabilities as well as efficiency and scale. There could always be some research on lock that creates, 10x more efficiency, 10x more density of knowledge, something like that. Yeah, I mean, I think that the other reason why there could potentially be some feelings around, how fast is this going to scale is the models are already so good. I'm running out of fun problems to throw at them that models can't generally do super well. Exactly. It's not just about the intelligence of the model. It's also about the intelligence of the question we're able to think up to give it.
The only one I've got that I'm convinced is going to still stand a year and a half from now is, without tool calling, generate a random number between 1 and 100. Great. Now I invoke it 100 times. Right now, the clustering in every model is overwhelming around some of the obvious candidates, 7, 42, et cetera. I don't think that LLM's architecture and structure lend itself to true random, but that's also a pretty esoteric, pretty weak benchmark as far as, okay, here's this one thing that they're bad at.
Well, the benchmark that I'm always going to have is write me a book called Inference Engineering. Make no mistakes, because, you have to remember that we're first off talking entirely about verifiable domains where you have an objective correct answer. And secondly, we are talking about models that are trained for a pretty narrow set of purposes around writing software, doing research, doing mathematics, and then kind of expanded to generalist capabilities. So when I think about, for example, the quality of writing, both at the sentence level, but also at the paragraph and page and chapter level, out of language models over the last couple of years, I don't see nearly the same level of improvement that I see in something like coding. Of course, there's a great improvement around factual accuracy, around consistency, fewer mistakes. But in terms of creating truly great writing that I'm excited to read, there hasn't been very much progress there.
No, and I think you're going to continue to see that struggle, because you take any distinctive writer who has a particular voice. You do, for sure. I do in some interesting ways.
But it's very distinctive. Don't worry.
But if everyone starts writing like this, suddenly you see it everywhere and it becomes obnoxious and annoying. I mean, I look at my writing from 2019. It's crawling with AI sign, parallel construction, multiple, it's not X, it's Y. The real story is, that's a load-bearing assumption. All of it. I sound like Claude. But if I had Claude in 2019, why am I not a billionaire? Because I didn't. It just trained on me and people like me.
Exactly. So, we're just going to have to continually evolve our styles and sort of stay ahead of the metagame, which you always have to do as a writer. It's just that, now the metagame moves much faster.
Just make it always talk like Foghorn Leghorn from the old Looney Tunes cartoons. That'll go well. What is going on with this code? Yeah, it'll go well.
Yeah. You have to have something.
Yeah. So we're getting drinks together in a couple weeks here in San Francisco, August 25th, 2006. 2026. Great time. What even is it now?
Yeah, I think if we were trying to get drinks together in 2006, the police would have a big problem with underage drinking at the bar.
For you, sadly not for me, which is a separate problem. Welcome to being old. It happens in the fullness of time to all of us. But also, I don't want people thinking that we're having this conversation in 2027 where everything we say is going to sound quaint and dated. If you're going to be around, feel free to check the link attached to this video, presumably, and come say hi. Let us buy you around.
Yeah, absolutely. And, we'll do it like this, but with everyone here, and we all get to sound off on our opinions on these topics.
Oh, terrific. Fortunately, without the lights and the cameras and the microphones, just nope, you, me, unfiltered, answering questions off the top of our head after 6 beers. It's going to be great because they all start with, what your problem is, and devolve rapidly from there.
Yeah. I don't know about 6 beers, but I'll do my best.
Thanks again, Phil. We'll talk soon.
Yeah, it was fun.